Hey everyone, welcome back. Today is going to cover Unit 8, Day 3 notes, which is going to be discussing multiplying polynomials, but this time with special cases. So our goal today is that students will be able to double distribute with special cases within 80% accuracy. So sometimes when we double distribute, we will find a few different special cases. So special case number 1, we have our two polynomials that we are going to multiply. And we notice that it's x minus 5 and x plus 5. So we're going to go through these steps and take a look and see what happens. So step 1 is going to repeat the step 1 we learned from double distributing yesterday in day 2 notes, which is multiply the first term by the first term. So let's go ahead and do that. X times x times x equals x squared. Beautiful. Second step will mimic that second step from day 2 as well. So multiply the first term by the second term. So x times 5, and we get 5x. Step 3, again, going to mimic that same step 3 from yesterday. Multiply the second term by the first term. So this is negative 5 times x, negative 5 times x, which gives us negative 5x. And then step 4, again, is going to mimic that one from yesterday. Multiply the second term by the second term. So negative 5 times positive 5, and we get negative 25. So our terms, x squared plus 5x, then we have minus 5x, and then we have minus 25. So the special case that's going to pop up is we have positive 5x minus 5x, and those will cancel out. They will equal 0. So we cancel them out, and we are left with x squared minus 25. So the special case we see here is that the second term, or the constant, is a negative 5 in one, and then it's opposite in the other polynomial. And when we do that, those middle terms will automatically cancel out, and we will get with a two-term expression, x squared minus 25 in this case. So that's special case number 1. So again, what did we notice? I kind of went ahead there and mentioned that before we got to this question. I got a little excited, so let's jot it down. The middle terms are opposite and cancel. Okay. Now, special case number 2. So we notice that we see one piece to this. Instead of two sets of parentheses, we have x plus 3, but then it's being squared. So in last unit, we would distribute that exponent, but that's because there was only one term on the inside of those parentheses. Now we have two terms, so we cannot simply distribute the exponent. Instead, before beginning to multiply, we have to write it twice. So that's what squaring something means, right? We're going, like if we had 4 squared, that's the same thing as saying 4 times 4, right? We have to write it twice. So we're going to do the same thing in this situation. So we have x plus 3 times x plus 3. And we've written it twice. Now we double distribute just like we have in the past, and then we simplify. So first term times first term, x times x gives us x squared. First term times second term, we get plus 3x. Second term times first term, plus 3x. And second term times second term gives us plus 9. Combine like terms, we get x squared plus 6x plus 9. Okay, so those are the two special cases that we're going to come across when we are multiplying polynomials. So a few more examples. We're going to go through 3 of them. The other 3 are going to be for you all to try. Number 1, right? Although we are talking about special cases for this notes, we have an example where we can't just assume we have special cases just as that first term is the same. In this case, it is not a special case. First term times first term is 25x squared. First term times second term gives us negative 15x. second term times first term, 5x. And then second times second gives us negative 3. So we do have to be careful and can't just assume it's a special case just because that first term is the same in each set of parentheses, 5x and 5x, because after we simplify this, we notice it is not a special case. 25x squared minus 10x minus 3. Okay, so if we go to example number 2, we do see it is a special case because we see that exponent up there in one set of parentheses, so we need to write it twice. I can't stress this enough. We cannot just distribute the exponent in this case. So we have 4x times 4x. First term times first term is 16x squared. 4x times negative 6 is negative 24x. Then we get negative 24x. And then we get positive 36. Now when we go ahead and simplify, these do not cancel out. It is negative 24 minus 24. And we get negative 48x plus 36. Okay, let's go through 2 more examples. I promised 3, we're going to do 4, because that first example is not a special case, whereas number 3 is a special case. We have a positive 10 and a negative 10, and the first term is the same. So again, when we take a look at these at a glance to start, if they are exactly the same except for the signs that are separating those 2 terms, then we know it's going to be a special case, and that middle term is going to cancel out. And we're going to go through it step by step just to show that that's going to happen. So r times r is r squared, negative 10r, 10 times r, 10r, 10 times negative 10 is negative 100. Middle terms are opposite. We have negative 10r, and then we have a plus 10r. Those cancel. R squared minus 100. All right, the last one we're going to take a look at is number 6. And the reason why we're going to do that is because we see there are 2 variables in this. And that's okay. We can still do this. It's still a special case because we are squaring. So 4n plus 5p times 4n plus 5p, right? We write it twice. We cannot distribute that exponent. 4n times 4n is 16n squared. 4n times 5p is 20np. 5p times 4n will give us the same. And just because we are multiplying 5p times 4n instead of 4n times 5p, we can still rearrange and write those variables in the same order. So we are going to get 20np. And then we get 5p times 5p is 25p squared. Now we combine our like terms. 16n squared plus 40p plus 25p squared. Oops, this should be np. Okay, go ahead, try the next 2 examples, number 4 and 5, and we'll come back and check in a second. See you in a few. All right, welcome back. Let's take a look at number 4. So again, with our polynomial being squared, we need to write it twice and then multiply. In this situation, in this special case, the middle terms will not cancel out, and we should get a trinomial when we finish. So 4m squared minus 12m plus 9. Number 5, we have 6x and 6x to start each of those, but then we have a positive 2 and a negative 2. So everything's the same except they are opposite terms as that second term in each set of parentheses. So when we multiply and distribute, those middle terms will cancel out, and we'll end up with 36x squared minus 4. Okay, awesome. Good job today. Make sure you reach out to your teacher if you have any questions. Otherwise, peace out. Have a good rest of your day.